Okay, the basics of waves. So a wave can be represented on a diagram like this. This is known as a transverse wave. It's a transverse wave because if you look at the way that this particle here at the top would be moving relative to the fact that the direction of the wave is travelling this way, this particle is going to move basically up and down. So we don't talk about it moving up and down or left and right. We relate it to the direction of travel. So the transverse wave is where the particles or the oscillations are at right angles to the direction of the wave. What we can measure on a transverse wave is we can find out our amplitude, and our amplitude is half the height of the wave from the what we call the line of rest, or the central part of the wave, to the very top, or you can measure it down here towards the very bottom of the wave. The wavelength is actually the length of one wave. Now the easiest way to be able to measure this is actually from the top of one peak to the top of the next peak. That's the easiest way, but you don't always have two peaks on a diagram, so you can't always measure it that way. The other way to do it would be to take your starting position at the point where it is crossing the line of rest. Let it go all the way through one peak and all the way through one trough, and then that's where you measure again. So our wavelength would be all the way across here. Wavelength is measured in meters, and so is amplitude. In the other thing that you can measure from the wave is your frequency. Your frequency is related to your wavelength. It's basically how many waves pass a point per second. It's measured in hertz, and hertz actually just means per second. So it's the number of waves per second. On your diagram, you also have to be able to label the peak or the crest of the wave and the trough of the wave as well, which are the highest and lowest points of the amplitude. You also have to know the equation, but this will actually be in your formula booklet, but you need to know how to use it. Wave speed equals wavelength multiplied by frequency. So if you have water waves and you say that you are standing somewhere and 5 of them pass you every second, then your frequency would be 5. To be able to get the wave speed, you would need to know how long the waves are. So you would need to say, oh, hold on, they're 2, let's say, meters. That's quite long for a water wave, but never mind. 2 meters times 5 hertz, and you would get 10 meters per second. When you're dealing with electromagnetic waves, which we will look at in another video, the wave speed of electromagnetic waves is always 3 times 10 to the 8 meters per second, and that is actually 3 with 1, 2, 3, 4, 5, 6, 7, 8 zeros. So that's the easiest way to think about that. When you've got electromagnetic waves, they always travel through that, in that speed through air. If they're travelling through something else, they do actually travel slower. But again, we'll deal with that in another video.